we're going to continue here with just some completing the square. I'll run through the first couple problems here, and then I'll let you try the next two on your own. Just pause the video, try the next two. When you come back to the video, the answers will be written for the next two underneath. You can check your work. And then we're going to move on to some more challenging problems with completing the square. So here we go. Let's start with this first one. I have x squared plus 14x minus 51 equals 0. We want to solve this by completing the square. If we're going to solve this by completing the square, the very first thing we have to do, remember, is we want to move that negative 51 to the other side of the equation. So I'm going to add 51 to both sides. And I'm going to leave a little space because I know I'm going to add a c value here that will make a perfect square trinomial. 0 plus 51 is 51. Now to figure out what this c value is, remember what I need to do is I need to take the b value, the 14, divide it by 2 and square it. So over here, 14 divided by 2 is 7, and I square that. I'm going to add 49, and that makes my trinomial on the left a perfect square trinomial. So now I need to add 49 to the right as well. Now I can factor this. Remember, this will always factor to x plus or minus, and if this middle sign here is a plus, I know it's going to be a plus, and it's just half of whatever the b value was. So 7 squared is equal to 51 plus 49 is 100. Now I can solve by taking square roots. I take the square root of the left and the square root of the right. I'm taking the square root because that square root cancels the squared. I'm left with x plus 7 is equal to the square root of 100 is both positive and negative 10. Here's where I need to break up my equation. I have x plus 7 is equal to negative 10, and I have x plus 7 is equal to positive 10. I solve each of these by subtracting 7 from both sides, and I end up with x equals negative 17. Subtract 7 from both sides, and I end up with x equals 3. So those are the two solutions to my quadratic. Okay, this next one, we're going to do the same thing. I want to move that 11 to the other side, so I'm going to subtract 11 from both sides. I have x squared minus 12x, leave a space, is equal to negative 11. I need to find the c value to add in there. I do the same thing. I take the negative 12 divided by 2 is negative 6, and I got to square that. That is positive 36, so I'm going to add 36 to both sides. That makes my trinomial on the left a perfect square trinomial that factors to x minus 6, the quantity squared, is equal to negative 11 plus 36 ends up being 25. Now I take the square root of both sides because this square root cancels the squared. I'm left with x minus 6 is equal to both positive and negative 5. Here's where I break it up. I have x minus 6 is equal to negative 5, and I have x minus 6 is equal to positive 5. I solve both of these by adding 6 to both sides. X is equal to negative 5 plus 6 is 1. My first answer. Add 6 to both sides. 5 plus 6 is 11. There's my second answer. Okay, so now you can pause the video, try the next two on your own, and then come right back and see how you did. Okay, the solution to the first equation on the left, you should have gotten x equals negative 4 and x equals negative 2. And the second equation on the right, you should have gotten x equals negative 1 and x equals 3. Those are the two solutions to each of these. If you did not get them correct, go back and rework them before you move on. Okay, so we're going to move down here. And the question is, can we still complete the square when the a value, the number in front of the quadratic term, and the x squared, can we still complete the square when the a value is not 1? And the answer is yes. However, what we want to do is we want to make sure we make it 1. Okay, so with this first equation, I'm going to do everything exactly as I would normally. I want to move this 20 to the other side, so I'm going to add 20x to both sides. So I should have 5x squared plus 20x, leave a space, and that's going to be equal to 60. Now, to make this a value a 1, I need to get rid of this multiply by 5, so I'm going to divide by 5, but I have to divide every single term in the equation by 5. When I do that, this x squared becomes, instead of 5x squared, it becomes just x squared, so that's good. And then 20x divided by 5 becomes 4x. And then the 60 divided by 5 becomes 12. Now I complete the square just like I normally would. I need to add a c value in here that makes this a perfect square trinomial. And the c value that I'm going to add is half of b. Half of 4 is 2. Squared is 4. So I'm going to add 4 to both sides. Now I can factor the left-hand side into x plus 2, the quantity squared, and the right-hand side becomes 16. Now I solve the way I normally would, taking the square root because the square root cancels the squared, and I'm left with x plus 2 is equal to both positive and negative 4. Here's where I break it up. X plus 2 is equal to negative 4, and x plus 2 is equal to positive 4. Solve each of these by subtracting 2 from both sides, and I get x is equal to negative 6. There's one solution. Subtract 2 from both sides, and I get x is equal to 2. 2 solutions. Now, this doesn't seem so bad, and it's really not. So I would like you to try this next one on your own. So go ahead and pause the video to try this next one on your own. And when you come back, we will have the answers posted here for you. Okay, welcome back. You should have 2 solutions. One of them is x equals negative 4. The other one is x equals positive 2. Okay. What do we do when the terms are jumbled? We really don't do anything different. Just remember, we want all the x's on one side, all the other numbers on the other side, and then complete the square as we normally would. So we need to move this 15 to the right-hand side. So I'm going to add 15 to both sides. And I need to add the 14x to both sides, because I want the 14x on the other side. These 15s cancel, these 14s cancel. I end up with x squared plus 14x, leave a space, is equal to 15. Take half of b, 7, square it, 49. So I'm going to add 49 to both sides. My left-hand side will factor to x plus 7, quantity squared. My right-hand side, 15 plus 49 is 64. Take the square root of both sides. Square root. Because the square root cancels the squared, I'm going to be left with x plus 7 is equal to both positive and negative 8. Split it up. X plus 7 equals negative 8. And x plus 7 equals positive 8. Solve each of these by subtracting 7 from both sides. X is equal to negative 15. There's one solution. Subtract 7 from both sides. X is equal to 1. There's my other solution. So you see, completing the square is really just the same thing over and over and over and over again. We're going to rewrite this one. Subtract 18x from both sides. And I have x squared minus 18x on the left. Leave a space. That's equal to 40. So I take half of 18 is 9, and I square it, and I get 81. So I'm going to add 81 to both sides. This left-hand side is going to factor to x minus 9, because that's half of my b value. My b value is negative 18. So half of that is negative 9 squared is equal to 40 plus 81 is 121. Take the square root of both sides, because this square root cancels the squared, and I'm left with x minus 9 is equal to both positive and negative. Square root of 121 is 11. I break it up. X minus 9 equals negative 11. And x minus 9 equals positive 11. Add 9 to both sides to solve. X equals negative 2. Add 9 to both sides. X equals 9 plus 11 is 20. Okay, so that'll be it for this first video. On the next video, what we're going to do is we're going to run into problems where they're a little bit more difficult just because there are more fractions involved. Okay, so get ready for that, and that next video is coming up very shortly.